Hello there, this is Miss Wesley again. We're ready for Unit 5, Skill 7, Part A. So this is one of those skills that's broken down. There's a Part A and there's a Part B. But Skill 7 is all about word problems. So I love word problems. Don't make fun of my drawings because I'm not the best drawer here. But our essential question for today is, how do you solve triangle similarity word problems? So we're going to use a lot of the things that we've talked about already in this unit to just kind of compile them because this is where you might see this in real life. The Regents loves to ask real life world problems, so you have to know how to solve them. Long story short. So our essential question for today, how do you solve triangle similarity word problems? Pretty straightforward. So we take a look at the first example here. It says a telephone pole is 10 meters tall and casts a shadow that's 8 meters long. So right there, they already told me two pieces of information. A telephone pole is 10 meters tall and it casts a shadow that is 8 meters long. Now, side note, shadows are always on the ground, my friends. So I'm going to draw a little picture here. Here's my telephone pole. Nothing fancy. And I know that that telephone pole is 10 meters tall. And it says the shadow is 8 meters long. So the shadow's on the ground. Oh, I wanted that to be in pink. Shadow's on the ground. That's pretty good covering that up. And it's 8 meters long. All right, picture one, done. Second sentence. At the same time, a tree casts a shadow that's 14 meters long. How tall is the tree? So here's my tree. And I know the tree casts a shadow that is 14 meters long. So here's my 14-meter shadow. And I want to know how tall the tree is. So here's my X. So I have two separate pictures. Telephone pole, the tree. Both of them are referring to the heights, and both of them are referring to the shadows. And since we know that trees and telephone poles both hopefully make a 90-degree angle with the ground, we can set up our favorite thing in the entire unit here, proportions. So you can either do height over height equals shadow over shadow, or you can do height over shadow equals height over shadow. Again, it doesn't matter as long as you pick corresponding pieces when you set your proportion up. So what I'm going to do here is I'm going to do telephone pole over telephone pole, and then I'm going to do tree over tree. So meaning my proportion would look like 10 over 8. So I did the telephone pole's height over the telephone pole's shadow, which means I have to do the tree's height, which is X, over the tree's shadow, which is 14. And again, that's just one possible option. If you did this a different way, see if it works out and you get the same answer as I do. So when we cross multiply here, 8 times X is going to give me 8X. 10 times 14 is going to give me 140. Divide both sides by 8. And what we will determine here is that our tree's height comes out to be 17.5. All right, and that's our answer. That's all we got to do. And again, just something to notice to check the reliability of your answer here. Notice that the tree's shadow was longer than the telephone pole shadow, so it makes sense that the tree's height is taller than the telephone pole's height. So again, just check those to make sure nothing seems off or funny here about your answer. All right, second example. A tree casts a shadow that is 15.5 meters long. So I know I have a tree, and it casts a shadow that's 15.5 meters long. Matthew is standing 12.4 meters from the base of the tree. So right there, I have enough information to sketch a picture. So I'm going to pause reading the rest of the question. I'm going to sketch what I know at this point. So when I have a tree, so here's my tree. And I know it casts a shadow that is 15.5 meters long. So from the bottom of my tree to, let's say, about here, I know that that distance is 15.5. It tells me that Matthew is standing 12.4 meters from the base of the tree. So Matthew, I'm going to put him about here. And I know that the distance from the tree to Matthew is 12.4. Okay. Now, if I keep reading, it says such that the end of Matthew's shadow meets the end of the tree's shadow. So all that's saying is that, okay, this distance from Matthew to the end of the tree's shadow is going to be Matthew's shadow. Their shadows are going to end at the same point. It then tells me if Matthew is 1.8 meters tall, so Matthew's height is, so if I do a little something something like this. He is 1.8 meters tall. Determine and state the height of the tree to the nearest 10th of a meter. So my goal here is to figure out, okay, how tall is the tree? So at this point, we have a lot of numbers, and we got to figure out, okay, which numbers should we actually use? And again, if we go back to that proportion that says we want to do height over shadow, and I'm going to tell you right now, shadows and heights are a really popular topic for the Regents. So if I was to do that, I'm going to set up tree height over shadow, and then Matthew's height over Matthew's shadow. So my tree's height is, that's what we're looking for, so that's going to be X. And I know the tree shadow it gave me was 15.5. So tree's height over tree's shadow. So now I need Matthew's height, and again it told me Matthew's height was 1.8, over Matthew's shadow. Now, Matthew's shadow is not 12.4, guys. It said Matthew is standing 12.4 meters from the base of the tree. So Matthew's shadow is actually this distance over here in orange that we don't know how long that is. But if we know that the tree's shadow is 15.5, Matthew is 12.4 from the tree, and their shadows ended at the same point, we can just subtract the 15.5 with the 12.4, and we'll figure out that Matthew's shadow is 3.1. So if you kind of look at this as, I'm just showing you my highlighter here, L's tree's height over tree's shadow, so X over 15.5, and then Matthew's height, 1.8, over Matthew's shadow, 3.1, that's going to allow us to finish our proportion. All right, so you always want to be able to make those L's when you set your proportion up, and now that you have your proportion, you can simply solve. So X times 3.1 is going to give me 3.1X. 1.8 times 15.5, that's going to give me 27.9. Again, I'm looking for X, so I have to divide both sides by 3.1. So meaning that the tree's height will come out to be, in this case, an even 9. So tree's height is 9. Again, remember that you don't want to put units on, because if you happen to put the wrong units, you lose points. So just leave them blank. It said to the nearest 10th, but since it came out evenly, I'm just going to leave it as 9. If you put it as 9.0, there's nothing wrong with that. All right, so hopefully these word problems are starting to make a little bit of sense here, and the most important thing that I can say so far is you have to draw a picture. You're not going to be able to figure it out just by looking at it and setting things up. All right, flip over to the next page. I think we got one, maybe two more examples to go. All right, just one example. This was on the first Common Core Regents they gave about 3 years ago now. It was a 2-point question. So here we go. Sorry about that beeping. I have no clue where that came from. All right, to find the distance across the pond from point B to point C, a surveyor drew the diagram below. The measurements he made are indicated on the diagram. Use the surveyor's information to determine and state the distance from B to C to the nearest yard. All right, so our goal is to figure out the distance from B to C. So I'm going to let that be X. So notice here we have two triangles. We have a lot of information given to us, so your brain should be thinking proportions, proportions, proportions. We just want to be careful here because you want to make sure you set up the correct proportion. So if we take a look at this, what we can do is we should notice that we have two separate triangles here. So my smaller triangle, triangle ADE, if I was to separate and redraw that, so ADE, I'm going to put my letters on it. So this is A. Oh, I didn't want that. Let's try it again. A. This is D. This is E. I know that from A to E is 230. And I know that across the pond at that specific point is 120. All right, now if I look at my big triangle, well, that's going to be from A to B to C. And again, I'm going to redraw that. A to B to C. Labeling my letters. A, B, and C. Well, I know that from B to C is what I'm looking for. So that's where my X is going to go. But A to C, notice that if I want to find from A to C, I need to actually add two of those side lengths together. I have to add the 230 and the 85. Well, 230 plus 85 is going to give me 315. So now that I have my triangles drawn, I actually could go back and add in the right angles. Now it's clear what my proportions should be. So looking at this, it doesn't matter what order you go in necessarily, but what I'm going to do is I'm going to put 230, sorry, I have no clue where that beeping is coming from, over 120, if you guys can even hear that, equals 315 over x. All right, and if you notice, I'm just going to take a second, I'm going to erase all this, if my pen will let me. All right, my pen won't let me do what it's going to do, but I'm going to switch it up here. What you want to notice here is what proportion I'm setting up is I'm doing the small side over the small base, so my 1L, similar to that proportion we did in the last one, equals my whole side over the whole base. And to get the whole side, we have to add the 230 and the 85. So now from here, again, we just go back to cross multiplying. 230 times x is 230x. 120 times 315 is going to give me 37,800. Divide both sides by your 230. We're going to come out with a number that is 164.3, what is that, 3478? It should be a 7. All right, but again, I said to the nearest yard. So if you think about it, yards, that's not saying nearest tenth, nearest hundredth. Nearest yard would be nearest whole number. So looking at my first decimal, there are 3. 5 or below, you let it go. Our distance here from B to C is going to be 164. Okay? So this was one of those where, again, you can separate and redraw, or if you're somebody that can look at it and say, okay, small side over small base equals whole side over whole base, whatever method works best for you. But these problems are very, very common on the exam, so you want to make sure that you can get those full 2 points. And let us know if you have any questions, but take a try at that practice and then work your way towards that CFU. See ya.